Good morning, everyone, or I guess now it's good afternoon, everyone, and thank you for joining us. Really excited to have everyone here today. I'm Wendy Heinzelman, the John and Barbara Bruning Dean for the Hagem School of Engineering and Applied Sciences, also professor in the Department of Electrical and Computer Engineering and Computer Science. And I am very excited to be here today. First, to introduce our speaker, Mark Bacco, but also to hear and to be able to present to everyone about one of our new transdisciplinary centers called SoundSpace. So, SoundSpace is a transdisciplinary center that brings together researchers, scholars, artists from across the university to explore and advance the interplay of music, sound, and technology. There's a long history of technology driven disruptions and adaptations in music, exemplified by interventions such as the gramophone and the creation of the music recording industry, as well as more recent developments such as the MP3 sound compression and the rise of online music streaming. Present day developments such as generative AI and immersive extended reality interfaces create new opportunities for musicians to achieve their artistic visions and reach audiences in compelling new ways. Today, we will explore how, through SoundSpace, the university is working to fulfill our mission of leading the way in the development and use of technology to preserve and advance music, the most human of art forms, and a medium for human expression, communication, and importantly, community building. We have a wide range of registrants joining us for this session, including alumni from the Hagem School of Engineering and Applied Sciences, from the Eastman School of Music. We have parents, students, faculty, and staff. And I welcome all of you here today. Before I introduce our speaker for today, I want to offer my deep appreciation to Bob Huang, who had the foresight to make today's program possible. Bob is a University of Rochester alumnus who made a significant investment in the University of Rochester in support of programming in technology and innovation. Today is the sixth virtual event for the Huang Speaker Series in Technology and Innovation. So thank you to Bob and to Lily for your support of the university. So today's featured speaker is Mark Bacco, the director of our Audio and Music Engineering program and a distinguished professor of electrical and computer engineering, who will talk about SoundSpace and the exciting innovations that are coming and will come from this initiative. So thank you, Mark, for being here. I'm going to now turn it over to you.
Okay, thank you, Wendy. I want to tell you today about SoundSpace, which is one of the transdisciplinary institutes that was founded in the last year here at the U of R. And SoundSpace is a broad activity that encompasses research, education, and engagement, both professional and with the community. And today I'm going to talk mostly about the research part of this. And this also, it's very exciting that this also led to the creation of a new department at the University of Sound Arts and Engineering that spans both Hagem and the Eastman School of Music and has faculty from both campuses as part of the new program. And I also want to emphasize that the research activities I'm going to talk about span more than just Eastman and Hagem. There are people from arts and science, the Med Center. We've even worked with folks in nursing. There are current projects with people in the Warner School. And so this is something that really spans the entire university. So, okay. So the outline of what I wanted to talk about today is to spend more time than usual. It's really easy with a diverse audience to for us engineering types to sort of get lost in the weeds, and so I'm trying to avoid that today. And I want to talk about the broader context of the SoundSpace Institute and how we're building on some of the history and existing strengths here at Rochester, and and then really the central concern in the research activities is to address what are really vital issues at the intersection of music and technology these days. And we don't want to be too self important, but we're trying to imagine what the future of music plus technology, how that's going to evolve and try to have some impact on the direction that things go. And I'm going to do that by talking about, in the second half of the talk, talking about a few specific projects that we're working on. One of them has to do with um, tracking the source of material used in generative AI for music generation. And so that's a big problem. That's a big concern to people in music and other areas. And then also talk about how we can make AI more of a collaborator and less of a replacement in music. And then some other projects that we're doing has to do with bringing musical experiences to audience in compelling new ways. And we also have a audio heritage preservation effort ongoing. And there's some interesting questions, both not just from the technical, but also the humanistic standpoint on that. So that's the outline of my talk. So the first thing I wanted to say, coming from an engineering environment, I'm surrounded by sort of hard-headed engineering types, and they want to know what's the impact of what you're doing. And it's easy for folks to think, oh, you're working on music, isn't that nice? And but my point I wanted to make first is that where music and technology meet and where those intersect media and many other sectors, there's a huge economic impact. And it's over $2 trillion a year if you add it all up across the sectors of music itself, just recorded music, concerts, all of that, cinema, television. Gaming is very large. The gaming industry is larger than the music industry, and then there are emerging markets. Podcasting is surprisingly large, but it also intersects audio, intersects consumer electronics, the built environment, and architecture, automotive, lots of different sectors. And so the impact of the issues that we are concerned with really has very broad um, reach. So that's the first thing I wanted to say. Now, I wanted to start off with a little bit of history. I think I like to read about history, and it's always interesting to see the parallels of what's happened in the past and what's happening currently. And at the turn of the 1900s, Rochester, as everyone knows, has been known as the imaging capital of the world for quite some time because of the huge impact of Kodak and Bosch and Lomb and Xerox and the local um, economic scene. But at the turn of the previous century, we were sort of the communication capital of the world as well. There was a company called Stromberg Carlson here in Rochester that was founded in 1894, and then they moved to Rochester about 1904, something like that. And they made telephones, and they were the largest independent manufacturer of telephones outside of Alexander Graham Bell's company um, in the world at that time. And so they were comparable in size to Kodak back if you go back to those days. And they were in the communications business. They made telephones, and then it evolved into radio, and then eventually television. And so that's an interesting thing to know about what the scene was when all of this started. Now I want to say a little bit about the University of Rochester's history and Eastman's history in the area of music and technology. If you go back to 1922, the first radio station in Rochester was founded by the University of Rochester, WHAM, which was originally WHQ back in when it was found when it first came on the air in 1922, was actually something that George Eastman provided the support to do. And the first, I don't know if it was the inaugural broadcast, but the first broadcast in 1922 was a live music concert from the Eastman School of Music that was just founded in 1921 with a gift from George Eastman. And there used to be a tower on the 52-foot tall tower on the roof of the Eastman School, and the broadcasting equipment was all located down there. And so the University of Rochester was the first to do that in the Rochester area. And the first commercial radio broadcast of any sort was in Pittsburgh in 1920. So this was really out. We're out on the cutting edge in the early 1920s with live radio broadcasts. And then eventually Stromberg Carlson bought the WHAM from the University of Rochester, and then they upgraded it to 50,000 watts, and so that and they're still on the air now. In the late 1940s, Stromberg Carlson built Rochester Radio City, which contained radio studios as well as studios for television, sort of the fledgling new media type in that era. And it's interesting that in 1956, the Eastman School of Music, when TV was, people were just really starting to get televisions at home, they hosted a live TV broadcast from the studios that are now WROC in this facility. And Howard Hanson was the host of this painting with sound series. It was on every other Saturday, and so anyway, that's interesting to know that we were Rochester was out in front back in the legacy of this. Now, I like to show this slide. It's really busy, but it's a timeline that speaks to the technology-driven disruption and how music has adapted. And as Wendy referred to in the introduction, I started this timeline with the invention of the phonograph in the late 1800s, and then there's a whole series of technical innovations that have taken place in the last 150 years that have been quite they've changed things quite a bit, and they looked like a considerable threat at the time. And so the Edison phonograph, when that came along, prior to that, music was a live event. If you wanted to hear music, you had to go to a concert. Or if you were lucky, you had a concert band and playing in the town park and things like that. Or, if you were really lucky and you were rich, you hired musicians to play in your house. And that's how people had music in those days. And when the phonograph came along and it was possible to record music, and then it became much more available. And there was a lot of consternation at the time that this is going to put all the musicians out of work. We just don't need all these live musicians anymore. And it did change the scene, but it created an entirely new industry of sound recording and the record industry. And so then if you look over time, there have been, when television came, and actually, if you go back to the beginning of the Eastman School, George Eastman was also a very pragmatic fellow. And one of the reasons he founded the Eastman School was to train organists for the silent movie theaters that were popping up all around the country. And it was good for business. If you wanted to show more movies, you needed trained organists for those. And so there were, in the organ department at Eastman is still preeminent. And but then in the 1920s, talkies came along, and so there's what did that do to all of the live musicians playing in theaters? Well, that changed that scene, but then it created another new industry of recording music for media. And this turned into what has been a hugely vital industry in Los Angeles and the West Coast, primarily in Nashville as well, for decades. So I won't go through this whole timeline, but then if you come up to the present time with the advent of AI, there's a lot of concern about what that's going to do to the music industry, just like there was concern back around 1900 or so about what mechanical recordings were going to do to the music industry back then. And I put the 1922 broadcast from Eastman and the early TV on this timeline too. Okay, so this brings me back to this first topic on the invention of the phonograph, and it's really interesting to see what John Philip Sousa had to say about this. So first of all, I want to see if this works. Here's a phonograph, an original 1909 phonograph, and it's a recording of Sousa's band playing a song that I think you'll recognize. So you get the idea. And I think you've all heard that on the 4th of July. And so Sousa was he was a composer. He was also the director of the Marine Corps band, or the Marine band, the president's own, sort of the preeminent military band in the country from 1880 to 1892. And he did not like this one bit, the mechanical music. And he wrote an article in Appleton's magazine, and about the title was "The Menace of Mechanical Music." And so it's a really amusing article with lots of opinions, but also some very clever drawings of mechanical music making babies cry, and the scourge of mechanical music taking over. And he said that he sees a marked deterioration in American music and musical taste, an interruption of the musical development of the country, and a host of other injuries to music in its artistic manifestations, by virtue, or rather by vice, of the multiplication of the various music reproducing machines. And he also, in his article, talked about what was probably the real issue, which was that the composers and the musicians were not getting paid, because Edison was making recordings and selling them, and there were no royalties to the people who created the music in the first place. Now, John Philip Sousa, having been in Washington for more than a decade running the Marine Band, knew a lot of people, and this led to the Copyright Act of 1909, which then assured that that musical works could be copyrighted, and then there should be fair compensation for that. And so this is an interesting parallel to what's happening today. I think if you look back, there was great concern about what technical innovation was doing to the industry, and there was probably took 15 years or so, 20 years for all of this to play out, and for an equitable, sustainable ecosystem to be put in place. And John Philip Sousa made quite a bit of money in his lifetime from royalties on his music. So that brings me to, I want to go to the next slide, and this thing is going to just take me ahead one little bit at a time. Let's see. No, I don't want. Here we go. Okay, so this brings me to the research topics that I want to talk about. So, the first one is tracking the source of material that is used in AI systems for creating music. I want to talk a little bit about that. And then some of the other topics I want to touch on, which are all represented by projects that are part of SoundSpace, are making collaborative AI assistants for music creation, and then the use of AI in preserving our audio heritage, and then change the subject a little bit to using new technology in augmented and virtual reality to reach audiences in new and engaging ways. Um, so, first, generative AI in music. So, you've probably heard of Suno, and they say that anyone can be a music creator in 60 seconds. They don't say a musician or a composer. You can create music. You can give this thing a prompt, and it will spit out some music. And I love this T-shirt, the AI seal of quality, and that I could I could try to lecture about the inferiority of the music that is created by systems like this and all of that, but that's rather self-serving. So I won't try to get into that subject and scold people for accepting the output of those systems as in calling it music. But let's talk about what we're trying to do about that. Now, I do not want to get into the weeds on the details, but I need to tell you just very briefly how these systems that create music work. And they use something, the ones like Suno and the most successful ones use something called an autoregressive transformer, which is also an example of that is a large language model, which is like underlying Chat GPT and Gemini and all of those systems. And the way they work is you take and you divide your content. It might be text, a computer program, or an audio file. You divide it into short bits in language. It could be words, punctuation, fractions of words. In audio, it's just could be short time snippets of sound or spectral related parsing of the sound. So you divide the sound into these tokens, and then a autoregressive model looks at the past history of those tokens and tries to predict the next one. And then it goes on and predicts the next one after that, and it goes on in that way. And it learns how to make those predictions by examining a whole bunch of training material. And so what you do is you develop a system that can make those predictions based upon what it learned from all of the examples that you gave it. And so then once the system is trained, a user provides a prompt, and then the system expands this sequence one token at a time and comes up with some kind of an output. And it's very well suited to language and code, and it works to a degree with music. It's pretty impressive what it can do. But it's basically just making predictions of the sequence of tokens, audio tokens in the music case, based upon what it learned from a large number of examples. Now, in fact, we've discovered on the way here that these sounds probably don't reproduce very well. But here's a example of how an autoregressive transformer, how tokenization works. So if I take a original recording and then I can break that into little tiny snippets. Now these don't, for some reason, come across very well. They're too short. But this thing is broken into 11 millisecond chunks of sound and then reassembled into the original sound. And so what you do, so defining these audio tokens is the first step, and you can use those to construct the original sound, and it learns how the sequence of tokens in the original sound, and then you can look at the sequences of tokens for a large corpus of sound and start to make predictions that if I know some set of, let's say you have a half finished song, you can look back, look at that and predict what's going to happen next with this model that's been trained. And so this is a case where I used a very small number of tokens, only 64, and it does kind of a lousy job. But it's possible to do a really transparent job using a few thousand tokens. And so Meta has a program called MusicGen, which they've published about, and so you can learn something about how that system works. And they use 8192 tokens, and they trained it on 10,000 songs. And the model, the trained model, has 3.3 billion parameters in it. So it's a formidable model. Suno, which is the leading commercial implementation, they claim they've trained it on tens of millions of training songs. They don't tell you anything about how it works, but just to give you some idea of what the music industry is facing, they've raised $375 million and they have more than 350 people working on this system. So they're very, very industrious and busy. And these systems work quite well, and but there's some shortcomings. And I've been witness to a couple of public kind of listening tests, where people giving talks and asking the audience if they can tell the AI generated music from something that the musician wrote. And it's uncanny that human listeners are almost unanimously able to do that. And so there's just something about, AI generated faces, for example. There's, humans are really good at looking at those and saying, there's something a little creepy about that. And so we have a very astute sense of being able to tell real from generated. But what these systems do well is they're very good at reproducing the tone quality and timbre, the local phrasing and instrumentation of music, but not so good at the larger scale structure. And in fact, there was this, and I'm not going to play an example because it's so dismal, but there was a country recordings of an AI generated band named Breaking Rust. I don't know where that came from. And this is the AI generated lead singer. And so you can, if you go Google Breaking Rust, you can hear. But that became the number one country digital download song on one of these systems. And it's a little suspicious what happens, because what people are doing now is they're taking making AI generated music, putting it on streaming services, and then they have bots do a whole bunch of downloads so they can extract payments from the streaming services. So the streaming services have not been terribly generous with musicians, and it's been an uneasy alliance there. But now there are pirates trying to take advantage of them. So we should be sympathetic to them now, I guess. Now the question, so that's sort of the background. The question here is, we're trying to figure out, is there a way to track provenance, and can we put a mark in music and track it? And so this is a huge challenge. Can we to put a mark in music that will last all the processing, maybe last through malicious attacks? And we've done work on this area for a couple of decades, actually, and we invented a type of watermarking that actually became part of the Blu-ray disc technology. Now, we're looking at other approaches, something called working in the Cepstral domain. But what this amounts to essentially is kind of remixing the audio, using the Cepstrum, which is the kind of the spectrum of the frequency spectrum. You can identify periodicities, and that lets you separate instruments to a degree. And we can do subtle changes to the remixing in this domain. And that does seem to give traceable evidence that propagates through AI generation. But this is a very challenging thing to do because we really do not have access to the proprietary models that the big commercial concerns have, and you have to test these at scale with tens of thousands to hundreds of thousands of songs. But we're working on that, and so this really, the purpose of that is to create a technology that would be the basis for having a new type of license. There is no copyright license now for AI training, and the places like Suno are just using everyone's material without permission. Now, there's lots of types of music licenses. The mechanical license, which is the one that pays the composers. They call it mechanical because it was mechanical gramophones originally. But there's some movement afoot to create a new type of license for material for training AI. And we're working on the underlying technology that would let you detect and track and enforce those kinds of licenses. So that's one of the things that we're doing that we're hoping has some impact. I'm going to skip that. So I want to spend in the last couple of minutes that I have, I always talk too long, I'm sorry, but I want to talk a little bit about some of the other projects, and I'll just be able to mention them very briefly. One of them is creating collaborative AI. And so Professors Dewan from the Hagem School and Temperley from Eastman are working together on creating a new type of transformer that is more suited to polyphonic music. And so music is not just a one-dimensional sequence of little events, but it's the overlapping of multiple voices that are timed and spaced to create harmonies. And so what they're trying to do is extend the fundamental approach to more of a 2D transformer approach. Another thing that I wanted to mention is that there's a team of people, Darren Miller and Michael Heilman from Eastman and Hagem are leading this on audio preservation. And they became interested in 78 records. And because there's a tremendous amount of material on 78s, and they were completely non-standard. And to preserve those, one has to make inferences about the equalization that was used to make those recordings. And then, so it's a matter of, to preserve the recorded legacy, it's a matter of getting rid of the noise, figuring out equalization, and getting the best signal you can out of the recordings we have. But then there's another thing that people are working on here, is on the topic of bandwidth extension. Because when you make an old recording like that gramophone, and then you listen to the real thing, well, the current, so there's a lot missing in the original recording. And you can, but you know that trumpets and tubas sounded the same in 1900 as they do now, more or less. And so you can just imagine what the original music really sounded like. And so if you can restore that to to what it would have sounded like if you had been there live, that's a compelling thing. But then that brings up the question of, well, are you restoring it and preserving it, or are you creating something that never existed? And so it's kind of like, we kind of think of the past with which is represented with a lot of black and white photos. You kind of think of the past as being in black and white. Well, it wasn't, but it's how do we want to remember the past and preserve it, and you don't want to add to it things that were never there, which is a danger if you start unleash AI on this. So that's a very interesting sort of humanistic question. And the last thing I wanted to talk about is using AR, VR to engage audiences. So if you go back to the history of Eastman's involvement in emerging technologies, first radio and then TV, the general idea was, how do we reach audiences and in compelling ways, and by taking advantage of the latest and greatest technologies. And so augmented and virtual reality are things that are quite compelling these days. In fact, there's another University of Rochester Transdisciplinary Institute on augmented and virtual reality. And we have a couple of projects that are going on, one with Sangmi Kang and others, on using AR and VR to give musicians and singers immersive experiences of being in an ensemble, and using this as a teaching tool. And then there's another thing that if you see this QR code, get out your camera and take a picture, and go to the University of Rochester 3D audio channel. So there's a professor, Minglun Lee, who's been doing all kinds of really great immersive audio recordings of Eastman concerts for several years. And so if you put on your headphones, you can see that there's a dummy head here in the middle of the Eastman saxophone ensemble, and you can put on your headphones and turn your head, and it's just like standing on the stage in front of them. And so he's extending that to the visual part of it as well. So you use binocular cameras that have two eyes, and then you can create 3D renderings of the video in AR, VR headsets. So I'm going to skip the rest of this because I'm out of time. And I just wanted to leave people with a quote and a thought. That this is from Leonardo, that he said, the study of science, he said, study the science of art. Study the art of science. Realize that everything connects to everything else. And that's really what we're doing, is we're trying to build this collaboration between musicians who are, represent excellence in their field, and sort of state-of-the-art engineering to really work together in a constructive way to help define the future for where this is going. And the last thing I wanted to say, a lot of you weren't even around in 1977, but in 1977, the Voyager 1 and 2 spacecrafts were launched, and on those were a record of the sounds of Earth, and that had recordings, everything from Bach to Bach's music to Chuck Berry, and sounds of waves breaking on the coast and that kind of stuff. But that could be the longest lasting artifact ever created by humankind, because it's predicted that these should survive maybe 5 billion years out in the galaxy, which is enough time for the galaxy to take about 20 spins, and the sun is going to be near its nearly out of fuel in that time, and so it's possible that the longest surviving artifact is going to be some music recordings from the 1970s. So that brings me to the end.
Great. Thank you, Mark. That was fascinating. I for anyone who has questions, please ask them in the Q&A, and we'll try and get to as many as we can. I want to start with a question about you talked about this new Sound Arts and Engineering department, and I personally am very excited about this. This is not only the first new department in the Hagem School in 25 years since biomedical engineering, but it is something that is uniquely Rochester, with being a joint department between the Hagem School and the Eastman School of Music. So I'm curious, a couple of questions from your perspective. Why was this such an important thing to do to create a new department? And then what programs will be part of this new department? So if students are interested in this area, what are the ways that they can study this field that clearly is going to be important moving forward, and including at the bachelor's, master's, and PhD level?
Yeah. Well, for the first thing, the like why create such a department? Well, there's lots of reasons. One of the key ones is that we have a number of faculty who are doing work in that really falls kind of in between the well-defined silos that unfortunately kind of exist in academia. So there are people who are really, I mean, this enables faculty to really cross boundaries and do things like develop new recording methods and things of that nature. And so it kind of frees up the faculty to pursue the things that they really want to do in this area, and it provides a home for students who come to Rochester who uh, really want to pursue music and technology or engineering at a high level both. Now the programs, there are a number of programs that this brings together. This is it spans the Hagem and Eastman, and it incorporates the Beale Institute, and there's going to we have existing majors, Bachelor of Science in Audio and Music Engineering, which is kind of hardcore engineering for people who go into creating technology in the audio industry. There's Audio Arts and Technology, which is a Bachelor of Arts degree, which is for people who are more interested in content creation and broadcast media, things like that. And there's a new major that was just approved at the Eastman School, approved by New York State, in music creation technologies. And that's going to be a Bachelor of Music. So we have a BS, BA, and BM degrees in this area. There's also master's degrees. There's a Master of Music at Eastman in film composition in the Beale Institute. There's a Master of Engineering degree that exists on the technical side. And we have doctoral students, both in the Hagem School and at Eastman, DMA and PhD students who can work in this institute. So we have education from three flavors of bachelor's degrees, a couple of flavors of master's degrees, and PhD and DMA pursuits.
And one question that came in was, is there anything in SoundSpace that's aimed at engaging musicians or composers with the basic sciences, things like physics and chemistry and those areas, as part of either SoundSpace or the new department?
Yeah, the one of the great challenges in universities is trying to, I hate to use a cliche, but like future-proof our students. And so the emphasis on fundamentals is really important. And so, the way we structure our undergraduate programs and the way the new Eastman program is structured is designed to give students a firm foundation in physics, enough mathematics to be functional, but not enough to hurt, and then areas like digital signal processing, and so giving people a more than just a user's literacy, but understanding the foundations of those fields so that they can contribute to their further advancement is one of the guiding principles of our educational program.
And what about from a research perspective? Is there any research in the fundamental sciences connected to music?
Um, yes, there are like in the area of spatial audio. There's been a collaboration with folks in biomedical engineering, and there are people in the Med Center and neuroscience who are quite interested in the science of hearing. And
Hmm.
so you have to understand how the brain encodes, how the auditory system encodes, and the brain processes sound to be able to create systems that actually provide the spatial sound experience that you hope they will. And
Right.
so connections with brain and cognitive science. There's a project in SoundSpace with a BCS professor, and then we do a lot of physics in the the acoustics work that we do. So
Right. Great. Another question that came in that said, I see a parallel with AI sampling sources and human created electronic music such as hip hop that samples music from other artists. How is copyright handled for hip hop if they credit their sources?
yeah, I am, you know, I don't know the details of that, but there are there are lots of high profile cases where people have sampled without license,
Hmm.
and there have been court cases, and they ended up paying, and uh, and so there is if you go about it in a fairly following the copyright rules, there are brands of licenses that one can obtain, and the license fees are variable, depends upon how well known the material is, um, and so there is a mechanism to do that fairly in the existing copyright framework, but there are several interesting examples of people ignoring that and then ending up paying eventually.
So you mentioned a lot of aspects of AI that are some good, some not so good in terms of the work that you're doing to be able to fairly pay musicians for their work that AI is kind of taking now to create new forms of music, shall we say. One question I had is about the use of AI for things like helping students learn to play music, because there's something, certainly you can use these apps and create music, but that's very different than learning yourself how to play the piano or how to play the saxophone or whatever. Are there tools? Are there people thinking about the use of AI in how to help students learn moving forward?
Definitely. I mean, there are things, you can build tools that just listen to the student practicing and provide feedback, but also there are video tools that if you're trying to play the violin and getting your technique right, and so there are definitely systems like that are emerging, and that's a great application, because the standard model now is someone goes for a music lesson once a week,
Hmm.
and there's no substitute for being able to sit down next to a really fine musician and experience their sound and see how they do things and all of that, and then you go away for the other 6 days and develop a lot of bad habits. If you're for, for, if you're like me, and so having reminders that can monitor what you're doing and keep you on the right track, I think are a really great application area and something we're very interested in. We worked with the oboe professor at Eastman a few years ago, trying to build an automated system that would would listen to an oboe student rehearsing and provide visual feedback so they could try to visualize their sound in some fashion and match it to the sound of their teacher or whatever they're trying to match.
And did that prove to be
Well,
useful?
you know what? We learned a lot because I had a PhD student who worked on that, and we created this system that had so many graphs and bells and whistles. The poor students were just overwhelmed by it. And so that was an example of what happens when you turn engineers loose without a lot of human computer interface experience.
Right,
And so it's a real challenge to develop interactive systems that provide the feedback you need, but not overwhelm the user
right,
with sound.
right.
And so we did another project with a jazz professor at Eastman to try to get bass players and drummers to play together more effectively. And so, like, in different forms of music, styles of music, the relative timing of the bass player and the drummer is very important. Is the bass a little ahead of the drum? Is the
Mm,
drum is pushing? And it has real sort of feel implications. And so we created something simple in this case where it was just you saw a display and there was a mark, like every time the bass drum was hit, there was a mark, and then the bass note, we just had like a bright dot. It was before or after. And
mm,
it's very hard to hear. If you can't hear it, you can't hear it. If you have to train your ear so you can pick up subtle timing differences. But providing a visualization and a simple visualization that would let the players know where they were playing relative to each other turned out to be really helpful in sort of developing their ear so they can listen for that more critically.
fantastic. That actually leads to what probably is going to be our final question because we're just about out of time. But outside of the technical aspects of the initiative and all the things that you're doing within Soundspace and the new Sound Arts and Engineering department, what are the humanistic elements that must be considered that might not necessarily seem obvious to the casual observer?
Yeah. Well, the one thing I referred to with the sort of the preservation and restoration, it's like, where's the line there?
Right,
And
right.
how do we want to remember our history and
Yep.
so that's a really interesting, compelling set of questions. And so that's one thing. Um, the other thing too is not to lose sight. And there's technical evidence uh, that supports the view that there's something we should not lose sight of, is that which is that people love to make music.
Mm,
They love to learn music, and they love to see other people perform music. And
mhm.
there's nothing like live music. It's just there's something magic about that, and there's a reason why people still do that. And so I think um, one of something on my mind is that we should never lose sight of that.
Right.
And the backup for that, the evidence I could present that truly is important. You look at what's happened with the with streaming. Musicians don't make money off recordings anymore, but Taylor Swift had a more than a year long concert tour, 23, 24, the Eras tour. It grossed $2 billion.
Yeah.
And so people want to hear live music,
Right.
and that's never going to change.
Right.
And so I think it's really important to keep that in mind, and and take everything we're doing, the technology, and do it in the light of what music is really about, which is about humans connecting and you know socializing. And, like, for example, I'm playing in the pit orchestra for my town's high school musical, and it's a blast. You know, it's
Yeah.
like there's nothing more fun than seeing 40 kids on the stage singing ABBA songs as I play the electric bass. So we can't lose track of that.
Yep. Well, I think that is a great note to end on for this talk. Thank you so much, Mark. That was fabulous. And I hope everyone enjoyed the presentation today. We will be sending out a recording of this in the next week or so. So look for that in your inboxes. And I hope everyone has a great afternoon. Thank you all so much. Take care.
Thank you.